the second video because I don't know which handout I gave you. So hopefully you'll be either watching this one or the other one to check your work. And let's start with this one. And let me just double check, okay, guys. Yeah, that's the right one. And we can start right away. All right, so I guess I'll just pretend that I didn't do the first one, or you didn't watch the first one. So again, remember we're adding like terms, and depending on the question, we might have to do this pretty properly in order to free up those terms from inside the parentheses, right? So they can be combined with the like term that's outside the parentheses. So first question here. The only thing I would do is really, and I want you to get used to, you don't have to, just for now, but when you circle it and identify your like term, so that's a 5C, and the other like term that's in here that's the same is plus 2C. And the important part here is that you circle the term, right, and the sign that precedes it. So that plus 2C that plus sign belongs to 2C. Okay, so you can't forget that. And then I'm gonna put a square on this one, and sorry, rhombus on that one. So the like terms are 5C. So imagine I had 4 rocks here, and I could move the rocks, right? Lift this rock and move it around. I put the plus 2C next to it. The plus 3D would be in third place, and in fourth place, plus 8D. What that does is it would put the like terms next to each other, and it just makes it easier for me to see. Now, when you're combining, it starts here, and it goes all the way up to before the sign, right, of the next term. So 5C plus 2, that's easy, is 7C, and 3D plus 8D becomes positive 11D. The better you get at this, and I mean, if I see you, if you take a quiz and all of these are wrong because you don't want to do this step or you want to take cut corners, then I think one of the things you might have to revert to is going through all the steps, right? But it takes a little bit of comfort until you get there. Okay, so again, here I will move things around. Negative 5m, and the other m that I have here is plus m. So I'll write those two next to each other. And then I'll have the plus 6n over here. I'll write the minus 7n over here. And the 8p is, sorry, the plus 8p all the way at the end. Okay, notice that I move the term, and that includes the sign that comes with it. So now it's just a matter of add and subtract. So negative 5m plus m, remember there's a 1 here, so m stays, it's negative 5 plus 1, and that's negative 4. 6 minus 7m, right? So it's going to be m again, sorry, n as in Nancy, and 6 minus 7 is negative 1, and then plus 8p. A little comment here on this. Although I wrote a 1, normally you will see it like this. All right? Because it's kind of redundant to tell you that I mean, how many n's do you see here? Just 1. So there's not it's not a necessity for me to write 1 n. You know, it's already implied that's 1 n. So you don't really need to write it. Okay? Okay, so again, moving like terms. And when we have variables with different exponents, the standard is to write the ones with the higher exponents first, and then write it in descending order. So we're going to write 3x squared. And then right next to it, I'm going to write minus 8x squared. Then the minus 5x, that's over here. And then the plus 3x. And then the constants, the 7 and the minus 9. So now it becomes super easy. 3 minus 8 is negative 5, x squared. Is there an x? Oh, I forgot an x here. 5x, negative, sorry, so it's minus, so you have to really be careful. It's minus 5x plus 3x, which is going to give us minus 2x. And 7 minus 9 is negative 2. Again, those of you, so you get negative minus 5x plus 3x. Okay. Oh no, that's not the one. I'm going to say just 3x squared minus 8x squared. If you're still not comfortable with the subtraction, you can, please change that to an addition sign, addition problem, by adding right? We add the opposite of the second addend, and then you can clearly see that it's going to be negative 5x squared. Okay? Don't cut corners until you're really comfortable. Here, the like terms are negative a squared with this guy. And then, oh, I'm sorry, I should have started with the AB's. So minus AB cubed, right? Minus AB cubed, right? Minus AB cubed, and then minus 8AB cubed, and then minus a squared. So let me just sort of write everything together. Minus a squared plus 5a squared minus a. Okay, so combine like terms. Again, you have to remember that there is a 1 here. You have to. Okay, so it becomes negative 1 minus 8 is negative 9, and we copy the variables. The second part is negative a squared plus 5a. Remember, there's a 1 here, so negative 1 plus 5 is positive 5a plus 4a squared, and minus a, just that's minus a. Now here we have finally distributive property, so I'll go over, slow down a little bit. So with distributive property, remember, you notice right away that there is a term inside those parentheses, the 9a, that can be combined with the 4a, but in order to do that, we have to remove the parentheses, and that doesn't happen automatically. So I'd like you to think that there's a 1 over here, and that 1 is going to be multiplied by every term inside the parentheses, so 1 times 9a, and 1 times that 3, right? So here we go. 4a stays. It's positive 1 times positive 9, so that's just going to give us 9a. And positive 1 times positive 3 is just 3. Notice that when it's a positive number, when it's a 1 outside, a positive 1 outside, the terms inside and the terms, and when you remove the parentheses, literally they're the same. It's positive 9, and plus 3, plus 3. Right? So let's combine like terms, and these are nicely together. So that's 13a plus 3. Over here, again, you don't see a number inside, so pretend there's a 1. Okay, I mean, this pretend there's a 1 is just for you to understand how we're removing the parentheses. I'm not just coming over here and erasing the parentheses. Okay, so if I multiply these two, right, so again, it's a positive 1. 1 times negative 6y is negative 6y. 1 times minus 4 is going to be minus 4. So as they were inside the parentheses, they come out because it's a positive 1 outside. And then minus 6y. Combine like terms. Let's move the like terms next to each other. Right, so I move this and this side by side, and then minus 4 went to the end. Negative 6 minus 6 is negative 12. Y minus 4. Erase. Okay, so let me just move down. Let me move this down a little bit. Okay, same thing applies. Now, here is where the difference is when there's a minus sign outside. So that becomes put a 1 in there. All right, so we got to remove those parentheses. So that minus will definitely affect everybody inside the parentheses. So think about it. Negative 1 times a positive b is going to be negative, and that's just going to be negative b cubed. Negative times this minus 1 outside times that positive, it's going to be a minus, and minus 1, and then 1 times 7 is 7a, right? So notice that it was a b cubed positive, it's now b cubed negative. It was plus 7a, it's minus 7a because of that minus sign. So every time you have a minus sign outside the parentheses, right, it's going to change everything to the opposites. And then here, look inside, we have 9b cubed minus 8a, right, and it's a plus. Right, so when if I remove the parentheses, right, if I remove these two, everybody inside comes out the same. So 9b cubed and minus 8a. So whatever they were inside, they are outside the parentheses, right? And again, that's the reason because I have a 1 here, and if I multiply positive 1 times 9b cubed, I get 9b cubed. Positive 1 times minus 8a is just minus 8a. Are there in like terms? Yes, there are. So let me move them side by side. So this guy and this guy will be next to each other. then minus 7a and minus 8a will be next to each other. Combine like terms, combine these two. Forget there's a 1 there, so it's 1 plus 9, sorry, negative 1 b cubed plus 9, it's going to be 8b cubed. And negative 7a minus 8a, it's going to be negative 15a. Okay? All right, so hopefully you're getting used to this. So again, the idea is that there's a 1 in here, and if you multiply, so if you either can think of it in this term, you can either, let me just write that again, right? So, and I'm going to add the 1 in there. So to remove the parentheses, right, we have to do this trivia property. And if there's a minus sign, everything that's inside comes out opposite. So negative 1 times positive 6 is negative 6c. So see the opposites. Then negative times a negative here. Negative times this negative, it's going to be positive. And 1 times 4 is 4m. So again, I keep telling you that they come out the opposite. So again here, the same thing. So I already know that the 3k is going to be minus 3k. And the plus 12 is going to be minus 12. And then, right? Because when you multiply these two, negative times a positive gives me a negative, right? And then this negative times this positive is going to give me a negative, all right? Like terms together, are there any like terms? So negative 6c, I'll put this in alphabetical order, negative 3k, and then 4m minus 12m. So I can combine these two. Final answer, minus 8m, right? Because 4m minus 12m is minus 8m. Let's see if I have room. Actually, I'm going to move this up a little bit. Okay, so again, let's do this. Okay, right? So negative 9d minus, so there's a 1 here, right? And that's a minus 1. So when we multiply by the terms inside, everything else is going to come out opposite. So that's a 2c inside the parentheses. Positive 2c is going to be minus 2c. It's minus 4d inside the parentheses, comes out as 4 positive 4d. And just 4c. Rearrange the problem. Minus 9d plus 4d comes next to it. The minus 2c comes to the back, and the 4c stands next to it. Combine like terms, these two. Negative 5, ooh, okay, so 4d, sorry, that's a d. So negative 5d, and these two is positive 2c, right? Because negative 2 plus 4 is positive 2. Here, we have to remove 3 brackets. So notice that in front of this here, it's a minus, right? That's a minus. That's a minus. So we know already that the terms inside are going to come out opposite. The only ones that come out the same is this one. Because here, right in front of that parentheses, there's nothing there. There's a positive 1 here. So 1 times a is just a. 1 times minus b is just minus b. It comes out exactly the same. Now this, that minus sign, right? Again, if you want to pretend there's a 1. Negative 1 times positive a is negative a. Negative 1 times positive b, negative times a positive is negative b. So notice it's backwards, right? Backwards, opposite, minus a minus b. And the last one, again, we can now take the shortcut. It's positive a, it's going to be minus a. It's minus b, it's going to be plus b, right? Because that minus sign changes everything to the opposite. So what can I do? Let me do a shortcut here. I know this is a positive a, and this positive a kills this minus a. This positive v kills this negative b. So really I'm left over with, and I'll write it in alphabetical order, minus a, this guy, and minus b. So the next question has, I looked it up actually while doing the other video, has braces, brackets and braces. Okay, so just before I continue that, so that we understand, Okay. Um, so if I had something like this, 5 times 2 plus 4, I would do this, and I would do this, right? Now with brackets, if this was like this, 7 plus 8, I would do the same thing. It's the same procedure. And then with this braces here, I would do this and I would do that, right? Distributed properly. So nothing changes, okay? So the only thing that changes is the order in which you're going to remove uh, the parentheses, the brackets, or braces. So right now, the first, so think of it as a prison maybe, right? The two terms that are in prison right now, you're going to release are the 5x minus 4. Those two are the first one that we're going to release. Okay, we remove that parentheses and that parentheses we're going to remove. So 10m plus 3, braces stay, and I'm doing it backwards. I should have done the other way. Okay, even worse. Excellent. So I'm just going to, oh, that's better. 3, right? And then 3m. And let's release the 5x and let's free the 5x minus 4. Notice there is a minus sign here. So as we know, when there's a minus sign in front of the parentheses that we want to get rid of, everybody who's inside comes out opposite. So that's a 5x, it's going to come out minus 5x. That's a minus 4, it's going to come out plus 4 in close braces. Okay, so that was the first thing we get rid of. Now that the parentheses are gone, the second grouping, right, symbol that we have to get rid of is this, right? So in order to get rid of that, we're going to apply the distributive property like that. Okay, so 10m, it's a positive 3, so positive times 3 times 3 is going to be 9m. Positive times a negative 5x is going to be negative 15, and don't forget the x. And then positive times positive is positive, and 3 times 4 is just 12. Now, these guys are also free. We release them from the braces. Right? Like terms, oh, lucky for us, they're next to each other. This is 19 now. Minus 15x plus 12, that has nobody, and neither does the 12, has no one to combine with. So that's it. So here, again, think of it, as prisoners, we're going to release the 6y plus 2 first, right? So we're going to remove those, but while removing, we have to pay attention to if they're on the sign outside and if there's anybody here to multiply, right, to do this distributive property. And in this case, we're pretending there's a 1 there. Okay, we're not going to write it, but pretend. So 4y squared minus 4y plus bracket 3y squared, and we're going to remove the parentheses. And to remove the parentheses, let's do this distributive property. So pretend there's a 1 there, right? Or know already that because it's a minus 1, everybody inside comes out opposite. So it's positive 6y, it's going to be minus 6y. It's positive 2, it's going to be minus 2, right? Because if you take that 1 and you multiply, right? Negative 1 times 6 is negative 6. That's negative 1 times 2 is negative 2. So we remove the parentheses, continue, plus 6, close bracket, braces. Now, we got to remove these brackets over here. Right, and to remove the brackets, the one person that may affect how they come out is this plus sign over here. Now, when it's a plus sign, it's a beautiful thing. It makes life so much easier. Here's my braces. And if you assume there's a 1 here, positive 1, that positive 1 is going to be multiplied by everything here, right? So when you multiply by a positive 1, everything stays the same. The signs don't change or anything. So 1 times 3y is positive 3y squared, minus 6y, minus 2, plus 6, right? Everybody inside the parentheses came out just exactly as they were. And close braces. Now, I finally get to remove these guys here. These guys have to go, right? The last grouping symbol. And what's going to affect that grouping symbol is this minus sign here. So because it's a minus sign, we already know that everybody's going to come out opposite. So 4y squared is going to stay, right? That's just not doing anything. So minus 4y, right? That 4y was positive, is now negative. This is going to be negative 3y squared. Sorry, plus 6y now. plus 2, and then minus 6. Okay, so they all came out opposite. Now we can combine like terms. Let me move things around. Minus 3y squared, so I combine this guy and this guy. Minus 4y plus 6y plus 2 minus 6. All my like terms are next to each other. These two first. 4y squared minus 3y squared is just 1y squared or y squared. Minus 4y and plus 6y is plus 2y. And then 6 minus 6, 2 minus 6 is just negative 4. Okay? Alright, so again, just a little, you just have to be careful, nothing else. Okay, continuing. We're gonna do the stereo property again. So 5 times d is 5d. 5 times 3 is 15, they're positive, nothing to worry about here. 5d plus 5, that was easy. Right, combine these two, we get plus 5. Next one, 5x times 2 is 10x. 5x times negative 3x is going to be 15x squared, minus 15x squared. Now we have minus x multiplied by 3x is going to be minus 3x squared, remember? When we're multiplying, we keep the base. If the bases are the same, we keep the base and we add exponents. And then minus x times negative 1 is going to be plus x, right? Because x times 1 is just x. Combine, like, let's put this in order, right? I move things around a little bit, okay? So these two came to the front, and this came to the back. So negative 15x minus 3x squared is negative 18x squared. And plus 10x and x is just plus 11x. Move on. So let's move. Again, I don't want to simplify too much, but it's not that complicated. Okay. Okay, so a little bit more a challenge here. Y squared times y is y cubed plus 4, and then y squared and y cubed is y to the 5th. Negative times a positive is a negative, and y times y squared is y cubed. Negative and negative is a positive, and y times 3y is going to be 3y squared and minus y to the 5th power. Let's put things together. Negative 9 to the 5th power, y 5th power, plus 4y 5th, they're side by side. And plus y3, plus y cubed and minus y cubed, they're just going to cross each other out, so I don't even need to write that. And then finally plus 3y squared, right? This guy right here goes off at the end. And negative 9 and 4 is negative 5, y to the 5th power, plus 3y squared. Final answer. Negative 2c times c is negative 2c squared. Negative 2c times positive 5d is going to be negative 10cd. And then we're going to do these two, right? Negative bc times 2a is going to be negative 2abc. Notice that I'm putting the variables in alphabetical order when I multiply them. And then negative bc times negative d is going to be positive bcd. Anything I can combine? No, because they're all terms with different variables, or different variables, or same variables with different powers, but they're definitely different. Okay, so no adding, which makes life much easier for me. All right, let's make any more room. I need a little bit more room. All right, so what is this? So here is an outlier. What is this guy doing here? Seriously. 3 times a is 3a, and then 3 times negative 5 is going to be negative 15. What? I don't even know why. Okay, no comments. All right, so it's really out of place. Next one, negative times negative is a positive. 2 times 4 is 8. Is there a's? No, so I just write a. B squared and b cubed is b5. C cubed and c to the fifth is c8. And then that's done, right? So let's do this one. Negative times a negative again is positive. 2 times 5 is 10. A and a cubed is going to be 8, 4. B squared was that b. It's going to be b squared was that b is going to be b to the cube and then c cubed. Let me erase this. And then we're going to multiply that times just a single b. So it's going to be a negative times a positive, which is a negative, and then the 2 a's be copied, and then b squared and a single b, it's going to be b cubed, and we write the c cubed. And then that whole thing times the little c there. Negative times a positive is a negative, and again 2 a doesn't multiply with anybody, b squared doesn't multiply with anybody, but the c cubed is going to multiply with that c, and that's going to get us a c to the fourth power. I doubt there's anything alike. I mean, this is ABC, ABC, but an ABC and ABC, but they all have different what they call exponents. So there's no term that's exactly the same power, sorry, exactly the same variable to the exact same power, so we cannot combine anything. Okay. Yeah, that's funny. All right, so not that much left. Again, we're multiplying. We're multiplying and then adding. That's what we're doing. Think about the simplicity of this. Right? We're multiplying and adding. So let's take this. So it's 12. That does nothing. That's the one that's doing the distributive property. Negative times a positive is a negative. 5 times 2 is 10. A. And then negative 5 and negative 11 is positive. 55. Combine like terms. Now combine this guy and this guy. So minus 10a plus 67. Next one, 4k times 2k is 8k to the second power. 4k times minus 8 is going to be negative 32k. Then copy the rest, because the rest is not doing anything. Let's move things around. Yes, there's this guy and this guy, right? They come first because although they share the k, they're k to the second power, so they're a little bit on, they're higher. So 8k squared minus 2k squared minus 32k plus 10k. So all my like terms are next to each other. And these two become 6k squared. And these two becomes negative 22k. Or minus 22k. All right. Yeah, that's it. Let's bring these fellas over here up. And we're going to, all right, so 7 times 3, positive and positive, no big deal here, 21w to the fifth power. 7 times 2, it's actually going to be minus, 7 times 2 is 14. That's it. This one, it's going to distribute 3 times. Positive and negative is a negative, 5km. And then 5m times negative 3m5 is going to be negative 15. M times m5 is m6. And then 5m is plus 7w is going to be positive 35mw. And then minus 30mw. Is there anything we can combine? Yeah, we can combine the last two because they're both mw. So you get 15 m6. Right, I'm going to write this guy first. And then this minus 5km. And 35mw minus 30mw is just plus 5mw. Okay. Okay, right, so the last question is a nice question. Okay. So we have 2 rectangles. Okay. And I want you to ignore the middle rectangle for a second and just focus on the bigger rectangle. So imagine there's that big rectangle. the width is 4x. No, battery, hang on. What battery does. Okay, so I hope it's charging. Yes, it is. So think about the last triangle, the big rectangle, right? So ignore the big rectangle. Ignore the small rectangle. That's what I meant. So the big rectangle, 4x is the height, and 3x minus 6 is the length. So in this case, we don't know the values, but it's expressed so that we know as far as the width is expressed by the expression 4x, and the length is expressed by the expression 3x minus 6. So if you had a rectangle and I asked what's the area of that rectangle, so let me just give you a numerical answer. I don't know. Skip this as 4 and this as 6. What would be the area? The area would be 24, right? 4 times 6. Now, what does that mean? It means that inside here, 2, 3, 4, 5, 6, and we have 4 rows here. It means that inside this rectangle, there are 24 square units. There's 24 squares here, right? Square units. Okay, of whatever, inches squared, centimeters squared, but we know there's 24 in there. So that's what we're measuring, and that's what area is, right? The amount of square units inside an enclosed figure. So in here, if I ask you to find the area, you're going to say, well, I don't know what, it's not a numerical value, but that's okay, because we can take the width, right? This times this, and the only thing is you can't write it like this. Because if you write it like this, the only thing that's happening is that these two are being multiplied. Whereas in reality, the length here is represented by 3x minus 6. So you have to put it in here because we're multiplying this whole thing times this whole thing, right? The whole length. And the whole length is not 3x, but it's 3x minus 6. So 4x has to multiply all of this. Okay, so that is key here. So let's multiply it out. 4x times 3x is going to be 12x squared. And then 4x minus 6 is going to be minus 24x. So this, the big rectangle, the area, we're going to write that the area, and I'll write it over here, is 12x squared minus 24x. Okay? So let me just keep that. So now imagine if you punch a rectangle. So you had, I don't know, something, and you cut this out. So imagine if you came here and you cut this out. Right? Cut a rectangle in the middle of that sheet of paper. You still have some left over, but we're trying to figure out how much left over you have. Okay, so that's what the question is saying. So how much did we just erase? Or, imagine how much did I just erase out? Well, the area that I just erased was this smaller rectangle. And the smaller rectangle is represented by 2x over here and x plus 2 over here. So let's find the area of this small rectangle. Like we did before, it's this, right? The width times the length. 2x times the whole of the length, which is x plus 2. I'll multiply. 2x times x is 2x squared. Plus, and 2x times 2 is 4x. So the area of the small rectangle here is, it's represented by the expression 2x squared plus 4x. So that's how much we removed from the big rectangle. We removed whatever this amount is. So let me write that the area of the small rectangle, small, is 2x plus 4x. 2x squared plus 4x. So let me do a numerical example here for you guys. Okay. So imagine, right? So, and we'll get back to our problem. So imagine we had a rectangle. Okay, we had a big rectangle, and this was 3, and this was 8. So the area would be 3 times 8, or 24 units squared, right? So it would be 24 units squared. So, and imagine, right, that area of the rectangle inside is 3 units squared. So imagine if I drew a square here, right? I traced, let me get another color. between a rectangle in the middle, right? And I cut that out. And the small rectangle, I don't know, let's make it a 1 and let's make this a 5. All right, the small rectangle is a 1 by 5, so the area would be 1 times 5, which is 5 units squared, right? And then I cut it up, right? And I cut that up. So how much of the original rectangle would I have? How would that be? In order to find that out, I would do 24, which is the area of the rectangle, original rectangle, minus 5, which is the area that I cut up. What I have left over is 19 units squared. Okay, so going back to our non-numerical, okay, so what was the area of the big rectangle? The area of the big rectangle is 12x squared minus 24x. And I'll put that in parentheses because this whole thing represents the area, okay? The whole thing represents this area right here. And from there, we're going to cut out a piece in the middle, represented by green. We're going to cut out a piece in the middle, right? This rectangle in the middle that you see here was cut out. And they cut out a rectangle. How much did they cut out? So we got to subtract the rectangle. And the rectangle in the middle is represented by 2x squared plus 4x. Now, the problem here is that you have to put this in parentheses because that's how much you're taking it out. If you don't put the parentheses, the only thing that gets subtracted is this part right here, right? But the area of the small rectangle in the middle is not 2x squared, it's 2x squared plus 4x. So you must put that in parentheses. Okay, so now we're going to subtract, and in order, before we can even subtract, we have to remove the parentheses. So the first one, you're going to say, why do we even put it in parentheses? But just to prove a point, just to stress a point that this whole expression represents the area of the rectangle. So then there's a 1 out there. If we multiply this, right, it's a positive 1, so it's a beautiful thing because nothing changes. Everything comes out the way it is, right? You'll notice that's 12x squared minus 24x, repeat outside. Now here, that minus is going to change, affect the terms inside. So we put a 1 over here, okay? You can imagine that, or by now I hope you already got used to that. If you know there's a minus outside, everybody comes out opposite. So positive 2x squared comes out of minus 2x squared. Positive 4x comes out as minus 4x. Can we combine like terms? We definitely can. Combine these two fellas over here. So we get 12x, put them next to each other. And then let me put the other two next to each other, minus 24x, minus 4x, like terms, right? So 12x squared minus 2x squared is 10x squared. And then these two, minus 24x minus 4x is minus 28x. So the area that's left over of my rectangle is expressed by 10x squared minus 28x. Let me write that a little neater. That's the area that's left over. Okay, so I don't know if you want to do the second sheet as more practice. You're more welcome to. Okay, so hopefully one of the two videos is actually the sheet I gave to you in class. All right, happy Halloween. I'll see you guys Monday.